This says use mental math strategies to divide. So I know that 42 divided by 7 is 6. This is 42 divided by 0.7. An equivalent fraction would be 420 divided by 7. So this is 60. Here I have 4.2 divided by 0.07. So if I multiply by 100, that gives me 420 and 7, because it moves the decimal 2 spots. This one I only multiplied by 10, which moves the decimal 1 spot. So this one is also 60. You can think about 28 divided by 7 and 20 divided by 4 with some of those mental math strategies to help you solve 1 through 4. So we know that 20 divided by 2/5 can be equal to something multiplied by the reciprocal or the flipped over version of that fraction. But can I just switch the order in a division problem? Let's use a different set of numbers to see if we can figure this out. Is 50 divided by 2 the same as 2 divided by 50? No. So if we just change the order, this is not the same. We are looking for ones that are equivalent, and we get to select all that apply. We know we can change this to 20 times 5 over 2 using that leave, change. Multiplication is commutative, so we can put the 5 over 2 in front and the 20 in the back. Just like if we had 2 times 10, that's the same as 10 times 2. So multiplication can change the order, but division we cannot. However, in B, I'm supposed to have 5 over 2, but they have 2 over 5, so that is not equivalent. This one says 20 times 5 over 2. Well, 20 times 5 would be the numerator, and 1 times 2 would be the denominator, so that one is equivalent. If we think about it as 20 divided by 2, that would be 10 times 5. Or we can think of this as 100 divided by 2 is 50. That's the same as 10 times 5. Can we just switch the fraction without changing the division symbol to multiplication? No. That is not equivalent. What if I put the 2 down here and the 5 stays on the top? Well, 20 over 2 is 10. And 10 times 5 also comes out to 50. So F is equivalent. Which situation correctly represents the expression shown? 20 divided by 2/5. A says a wooden board is 20 inches long. The carpenter trims 2/5 an inch off the end of the board. Trims would be a subtraction, how much of the board remains. So that would be 20 minus 2/5, not divided. A bag of pecans originally weighs 20 pounds. How much does the bag weigh when only 2/5 of the pecans are left? Okay, this would be if only 2/5 were left, that would mean we need to figure out what 2/5 of 20 would be, which would be a multiplication problem, 2/5 of the 20 pounds. So this is not a division problem. Remember, this was a subtraction problem. This one was a multiplication problem. We could also write it the other way and still get the same answer. The width of a painted mural is 20 feet. You paint a border on one edge of the mural that is 2/5 feet wide. How wide is the mural now? So if it was 20, we would add 2/5 to one end and 2/5 to the other end. Like, for example, we would put a border of 2/5 here and a piece that's 2/5 here in addition to the 20 that's already there. So this isn't quite it either. You have 20 meters of ribbon and you want to cut the ribbon into sections of 2/5 meters to create bows for your soccer team. That word cut or split indicates division, so D is correct. Without actually evaluating these quotients or finding out the answer, can you tell which ones will be greater than 1 or less than 1? This is approximately 2 split into 7 parts. If you split 2 into 7 parts, each of those parts is going to be less than 1. This is about 5 split into sections that are about 0.4. Are you going to get more than one section that's 0.4 out of 5? Yeah, you can get multiple 0.4s to make a 5. So this is going to be more than 1. Here I have 4/10 and 32 hundredths. Is it going to take more than 1 or fewer than 1 32 hundredths to make 0.4? This is actually going to take more than 1 of these to make this amount. 18 hundredths and 9/10. Is it going to take multiple 9/10 to make 18 hundredths? Well, no, 9/10 is already bigger, so this is less than 1. For problems 5 through 10, divide. Some strategies you may use are writing them as long division problems. You may also need to adjust the decimals in those long division problems. So for example, if I had negative 0.9 divided by negative 0.4, I'm going to move the decimal to the right one spot to get a whole number here and one spot to get a whole number there. So now I have negative 9 divided by negative 4. A negative divided by a negative comes out to a positive answer. 4 fits into 9 2 times, giving them 8. Don't forget your decimal. 9 minus 8 is 1. Bring down a 0. 4 fits into 10 twice, leaving you with 2. And 4 fits into 20 5 times. So the answer to number 5 is positive 2.25. Here I have 1.97 divided by a negative 7, so that's going to be a negative answer. 7 doesn't fit into 1, so we put a 0 there, but it does fit into 19 2 times. 2 sevens is 14. 19 minus 14 is 5. Bring down the 7. 7 times 8 is 56, leaving us with 1. Bring down a 0. 7 fits into 10 one time, giving us 3. 7 fits into, oh, I should have had a 6 there. That would have changed things. That would have been 0. So it should be 0.28. Negative 0.28. Make sure you copy your problem down correctly so you don't end up in that situation. Okay, now I have negative 0.45 divided by negative 0.375, and negative divided by a negative, those are the same signs, so it will be positive. We're going to move the decimal 3 spots, so we need to do the same thing here. So now I have 375 and 4,500. All right, 375 fits into 451 time. Borrow. 10 minus 5 is 5. 4 minus 7 we'll need to borrow again. 14 minus 7 is 7. Bring down the 0. I believe this is going to fit in twice. Let's check. 375 times 2. 5 times 2 is 10. 2 times 7 is 14, plus 1 makes 15. 2 times 3 is 6, plus 1 more makes 7. So that is exactly 12. Positive 12. All right, this one you can rewrite them as decimals because they have 10 and 100, so they are in decimal fraction form. This would be a negative divided by a negative, so same signs gives you a positive. That is 4 tenths and 32 hundredths. You can solve it using decimals, or we can use the leave change. So that would be 4 tenths, change to multiplication, change the fraction to the flipped over version. 4 times 100 is 400. 10 times 32 is 320. We can reduce this. That would be 40 over 32. Both of those are multiples of 4. It takes 10 fours to get 40 and 8 fours to get 32. These are both even, so they're multiples of 2. We can change that to a mixed number, which is 1 and 1/4, or as an improper fraction in its reduced form is 5/4. Same thing for number 9. We can use the leave change method. I have a negative divided by a positive, so this one will be negative, times 10 over 9. You can also simplify as you go. 10 and 100 are both multiples of 10. 9 and 18 are both multiples of 9. 2 times 1 is 2. 10 times 1 is 10. Or we can reduce that to 1/5. Don't forget that it is negative. Same thing here. This is going to be a negative. I have 3/4 divided by 24 25ths, which can be changed to multiplication and the flipped over version. 24 and 3 are both multiples of 3. It takes 1 3 to make 3 and 8 3s to make 24. 1 times 25 is 25. 4 times 8 is 32. This cannot be reduced, so this one should say negative 25 over 32. For problems 11 through 14, also dividing. 3 tenths can be rewritten as 0.3, and 8 tenths can be rewritten as 0.8. This is a negative divided by a positive, so our answer will be a negative. We'll move that decimal 1 place here and 1 place here, so now I have 3 divided by 8. 8 does not fit into 3, but it can fit into 30. 3 times would give us 24. 30 minus 24 is 6. 8 fits into 60 7 times. That would give us 56. 60 minus 56 is 4. Bring down another 0. 8 fits perfectly into 40 5 times. So number 11 should say negative 0.375. 12 is a positive divided by a negative, so it should be a negative quotient. 25 tenths can be rewritten as 2.5. We'll move that decimal over 1 spot, so now I have 25 and 51. 25 fits into 51 twice, giving us 50. 51 minus 50 is 1. It doesn't fit into 10, but it does fit into 100 exactly 4 times. So this is negative 2.04. This quarter can be rewritten as 0.25 divided by 0.6. These are both negatives, so they are the same sign, giving us a positive answer. I'll move this to the right once and to the right once there as well. Now I have 22.5 divided by 6. 6 fits into 22 3 times. 6 times 3 is 18. 22 minus 18 is 4. Bring down that 5. 6 fits into 45 7 times, which would give us 42. Then we would subtract, giving us 3. Bring down a 0. 6 fits into 30 exactly 5 times. And it is positive 3.75. This is 10.8 divided by an 8. The answer is going to be negative. I could write this as a fraction since 1/8 isn't an easier conversion to a decimal. This would be 108 over 10 because it's in the tenths place. Divided by 1/8 could change into multiplying by 8 over 1. 8 and 10 are both multiples of 2. It takes 4 2's to make 8 and 5 2's to make 10. 100 times 4 is 400, and 4 times 8 is 32. 5 times 1 is 5. We can leave it as an improper fraction, or we can think about how many 5's it would take to make 432 if we wanted to change it into a mixed number or a decimal. The product of two numbers is negative 0.75. Find two different pairs of rational numbers that have a product of negative 0.75 and show that your answer make a true number sentence. Well, 75 is 3 sets of 25, but we need one of them to be negative. Oh, I wrote a 2 instead of a 3. 3 times 25 is 75. So if I have 0.25, that would be 0.75. Another possibility is positive 0.75 times negative 1 would be negative 0.75, because a positive times a negative results in a negative. Then it says the quotient of the two numbers is negative 0.75, so we need to divide two values to get negative 0.75. Find two different pairs. Well, we could do 0.75 times 2, that would be 10, 14, 15 with 2 decimal spots. So we can make this 1.5 divided by 2 would get us back to that. One of them needs to be negative though. And it does say show that that would make a true number sentence. So 1.5 divided by 2. 2 fits into 15 7 times. And 2 fits into 10 5 times. Another possibility is if we did 0.75 times a higher number, like 4. 4 times 5 is 20. 4 times 7 is 28. Plus 2 more makes 30. So that would be 3 and 4. We can think of it as 3 divided by negative 4. would give us 0.75, but the negative version. And we know 3/4 is 0.75, so 3 divided by -4 would be negative 0.75. For this quotient task, so you get to use the numbers 1 through 9, but you only get to use them once. And your goal is to create a quotient that is the smallest and a quotient that is the greatest. So you might start by placing a 1, a 2, an 8, and a 7 to see what that would come out to. And that would give you 2 over 7 times 8 is 56, or 1 over, if we reduce by 2's, 56 split into 2 parts is 28. Could you get something smaller than a 28? What if we changed this to 9, for example? Okay, now I have, if I did that, then I would end up with 1/8 times 2 over 9. 1 times 2 is 2. 8 times 9 is 72, which reduces to 1 over 36. A 36 is smaller than a 28. Can you come up with one smaller? How about what quotient would create the biggest? What if I swapped those? What if I did 9 over 2 and 1/8? Would that make a large quotient or a small quotient? Remember, leave, change, change. These have factors of 2 in common. 9 times 4 is 36. 1 times 1 is 1. So I was able to get a quotient of 36. Can you get something bigger? You're going to find one quotient that is the smallest using the numbers 1 through 9, and one quotient that is the biggest. But keep in mind you don't get to reuse the same number. So you can't do like 9 and 9 here and a 1 and 1 here. You have to use 4 different numbers between 1 through 9. Give it a try and see if you can come up with something else. Make sure your warm-up is finished and your workbook is filled in for lesson 22.